Hello, Course 3 students, and welcome to our 6th lesson here in our Chapter 4. We're getting closer to finishing up this chapter as it is a little bit of a longer chapter. I believe we have one more lesson after this lesson to get through before we will spend some time more so reviewing the rest of this chapter and getting ourselves ready for the test. So today, for lesson 4.6, it is all on estimating square roots. So yesterday we talked about perfect squares and being able to solve perfect squares. Today we are going to be looking at square roots where they're not going to be as perfect. I'm not going to know it off the top of my head as easily. So this is a really good example of actually the first problem we're going to be doing here. So they're asking for the square root of 34. Well, I don't know any number times itself that's going to be 34. I could take something like, a different number times a different number and get 34, but I need the same number times itself. And so they're showing that 34 is in between the perfect square root of 25 and the square root of 36. Well, the square root of 25 is 5 and the square root of 36 is 6. We can use those measurements to help us determine a value for the square root of 34, which is about 5.8. So this is where we're going to get answers or solutions that have decimal values and aren't nice, clean, whole numbers. So our objective is I can learn to estimate square roots and solve problems using square roots. So this one is just kind of a reminder here. This is part of your textbook. It says a couple wants to install a square stained glass window with wood trim. You can calculate the length of a trim using your knowledge of squares and square roots. Recall that a perfect square is a number whose square roots are integers. For example, 25 and 10 are perfect squares because if I take the square root of 25, 5 times 5 gives me 25, so my solution is 5. Square root of 100 is, I think, what number times itself is going to give me 100, which is 10. You can use the square roots of perfect squares to help you estimate the square roots of other numbers. And that's what we're going to do today, is we're going to use what our already known knowledge of these to help us estimate not perfect squares. So our first example is, and this is always tricky to type out square roots on here, but the square root of 30 is between two consecutive integers. Name the integers and explain your answers. So I think the best way in this one is to remembering what are these values squared. What's going to get me close to 30, what may be a little bit more than 30, but also what's going to be less than 30. So I'm going to remember back to my squares. So if I did 1 squared, well, 1 times 1 is 1. 2 squared is 4. Well, it's not high enough yet. I need 30. 3 squared is 9. 4 squared is 16. Still not quite there. 5 squared is 25. We're pretty close. And 6 squared is 36. Oops. So actually, my values are in between 25 here and 30. So it's very similar to that first problem on that page, actually. So what they're saying is that the square root of 30 is going to be greater than the square root of 25. I can't write today. But it's also going to be then less than the square root of 36. So remember, the square root of 25 is 5, because I said 5 squared. And the square root of 30, we don't know the square root of 30 off the top of my head. And then the square root of 36 was 6. So all they wanted me to do was name the integers that it's in between. So I'm going to say 5 and 6. It is in between 5 and 6. And just to explain, it does say explaining. So maybe showing out some work like this, Or you could write between, 5 and 6 because 5 squared is 25 and 6 squared is 26. 30 is in between those two numbers. That's another way to explain it. I'm not just going to necessarily write it all out, just for the sake of time for this video. The two integers it's in between is 5 and 6. So let's take a look at another example. It says, while searching for a lost hiker, a helicopter covers a square area of 150 miles squared. So this helicopter is going around in a square, I guess, and he's kind of looking in this area that this hiker might be. What is the approximate length of each side of the square area? Round your answer to the nearest mile. So in this case, I am going to square root this value. Remember, this is my total area. If I want to find the square root or the side of one of them, I'm going to take the square root of it. So again, I want to figure out what two numbers it's in between to then help me figure out how I can figure it out, decimal wise, or it says round to your answer to the nearest mile. So in this case, I don't need decimals. I want a nearest whole mile. So this one's a lot larger. I might start thinking about my squares at like 10. I know that 10 squared is 100. But that's not quite as big as I need. What about 11 squared? 11 squared is 121. 12 squared is 144. Kind of just been learning based off of, knowing my multiplication tables. If you're stuck on them, multiply it out. But 13 squared, if I was to figure that one out, I get 169. Well, 150, if I notice, is in between 144 and 169. So I could show that as 150. We can still show this, as greater than the square root of 144, but is less than the square root of 169. Now, they want me to decide to the nearest value, because remember, this means 12, and this means 13. So is the square root of 150 closer to, sorry, I wrote this as 12, 13. Is it going to be closer to 12, or is it going to be closer to 13? Well, to help me determine that, I'm going to decide how much difference these two numbers underneath the square root is. And I think actually adding in a different color will be helpful. So if I wanted to find the difference between 150 and 144, remember that means subtraction. And there is a difference of 6 between these two values. But over here, if I take it, again, I'm just going to take the largest, 169, find the difference, subtracting. I end up getting a difference of 19. So I want the one with the smaller difference, which is this one over here, which means that I would pick my solution to be 12. Round your answer to the nearest mile. So 12 miles would be my answer. All right, I think we've got, I can't remember if there's 3 or 4 examples in this one. Looks like we've got more than one. All right, so next one, though, we need to approximate the square root of 200 to the nearest hundredth. Woo! Hundredth, that means I need 2 decimal places. So again, I want to think the square root of 200 is close to what two numbers? Let's start with that. Again, I know that 10 is the square, or 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. Now, we didn't talk about 14 squared. In this case, I'm okay if you want to grab a calculator to double check, but that would mean 14 times 14, which gives me 196. So we're close, but not quite to 200. What about 15 squared? So 15 times 15. Well, that gives me 225. So it looks to be that the square root, and I think I'm going to get rid of that other blue again. The square root of, I think we're just going to write this over here. Square root of 200 is less than, or is greater than the square root of 196 and less than the square root of 225. So that means it's in between 14 and it is in between 15. Now, looking at this, again, finding that difference is going to be also helpful so that you understand, is it going to be closer to 14 or is it closer to 15? So I'm going to say that this one is closer. Let's look at our difference. 200 minus 196 is 4. 225 minus 200 is 25. So it would actually be closer to 14, but they want me to have 2 decimal places with it. So what if I did something like, I don't know, I'm just going to kind of guess. Sometimes I just have to guess. It's closer to 14, and there's only a 4-point difference. So what if I did something like 14.15? Let's check that in a calculator. If I did 14.15 squared, meaning I multiplied it by itself again, so 14.15 times 14.15, wow, I actually got pretty close on that guess. It was 200.2225. I wonder if we can get closer though. What if I did 14.14 squared? Is that going to be actually closer to 200 with not as much decimal? Oh, this one gives me 199.9396. Ooh, so I got to figure out which one's closer to 200. Is 200.2225 repeating, or is 199.9396? So in this case, I could find the difference between the two. In this case, if I did this number minus 200, you'd be left with just the decimal of 0.2225 repeating. In this case, if I took 200 minus this number, I am going to get 0.0704, I think. So in this case, this is actually going to be your closest. So, and then we don't actually keep that square there. So your closest or to the nearest is 14.14. And sometimes it just takes some estimating or guessing. We knew that it was closer to 14, and then I just kind of come up with 2 numbers. It was closer to 14. You know, 15 is pretty close, or it's a smaller decimal. It's meaning it's closer to 14, and just kind of work your way through it. If that's a little tricky though, sometimes we are allowing you to use the calculator. So this time it says use a calculator to find the square root of 700. Round your answer to the nearest tenth. So this just means 1 decimal place. So here's what I'm going to do. If you have a calculator with you, if it's the traditional kind of like this one, what you're going to need to do is you're going to need to press the second button. It's usually a blue or yellow button. And then there is a button that has x squared on it. You're going to press that x squared button. And that should bring up a square root for you. Okay. From there, all I have to do is press in 700. And then I can set it equal. So when I did that, I got 26.4575131. But remember, my directions say round to the nearest tenth. So I only want the first decimal place. And remember, that second one is going to help me determine if I need to keep it at 4 or if I'm going to round it up. So in this case, because it's a 5, we round up with 5 or more. So I'm going to round this up to 5 instead of a 4. So I'm just going to make it 26.5. And that's how it solved this one. All right, let me know if you got questions. We'll continue working on it in class.